On this 2015 to 2025 Ford F150 with the 2.7 EcoBoost, P0174 may point to a lean air-fuel condition on one side of the engine. The truck may idle rough, hesitate, feel down on power, or turn the light on with few obvious symptoms. Broadly, this can involve possible unmetered air, intake or vacuum leaks, fuel quality or fuel delivery concerns, exhaust issues, wiring and connector problems, or sensor input problems. The path here is a gateway diagnostic approach. Prove the concern is present, do the basic checks, then route the testing correctly. It does not provide a P0174 specific pinpoint sequence, so do not guess at parts or thresholds that are not proven by the checks. First, confirm the customer concern is actually present. If it is not present while you are testing, do not replace modules or components just because a diagnostic path might point that way. Then make the normal preliminary pass. Look for anything obvious related to the symptom. Check any available OASIS or TSB information, and look closely for previous repairs that may not have been completed correctly. Before going deeper, make sure the battery and charging system are operating correctly, and verify battery SOC is greater than 70% before beginning diagnostics. Next, scan all network modules for system or symptom codes that may help decide where to start. If other codes are present, check what they mean first. Circuit-related codes get diagnosed before system or performance type codes. And if multiple circuit codes are present, look for a shared cause, like a common power or ground feed, instead of treating every circuit as a separate failure. Now, slow down and inspect the basics. Check wiring harnesses for damage, chafing, and correct routing. Check fuses, electrical circuits, and connectors for continuity and correct installation, and make sure components are fully connected. For a lean type concern, the air side matters. Inspect vacuum lines and the air intake system for leaks, routing problems, and restrictions. Inspect hoses for damage, leaks, blockage, and correct routing. Check fuel quality, including octane, contamination, and winter or summer blend. Inspect the fuel tank and fuel lines for damage, leaks, and routing. Also check coolant level and quality, with the engine operating at the correct temperature. Check oil level and quality, and inspect the exhaust for damage, restrictions, and routing issues. When you connect test equipment or jumper wires at pins, use Rotunda Flex Probes MUD 105 R025F or Terminal Probe Kit 418 S035 so you do not spread or damage terminals. Check male to female terminal fit with the mating pin and look for normal separation force. A damaged pin will have very low separation force. If the connector shell, pin guide, or retainer is adding drag and hiding the feel of a small terminal, remove the pin from the connector shell so the separation force can be checked correctly. Replace damaged connectors, pins, or terminals. Then use the scan tool for PID input values, output states, and diagnostic states. Monitor PIDs in the data logger, and use output state command PIDs where applicable rather than tearing into the vehicle too early. If testing moves into module-controlled operation, understand the function you are checking. Make sure programmable parameters are set correctly. And if the diagnostic path tells you another DTC has to be handled first, resolve that DTC before continuing. Test the module inputs, both hardwired and networked. Then test outputs, check for module software updates, and use the scan tool output control function to command components on and off, where applicable. If the output side tests normally, shift your attention back to the inputs. Do not apply power or ground directly to module-switched components with jumper wires unless a directed test specifically calls for it, because that can damage the component. For power-providing circuits, do not rely only on a voltage check with the intended load disconnected. That kind of test may only find an open fuse or an open circuit, and it can miss excessive resistance. For circuits carrying approximately 200 to 1000 milliamps, load the circuit with a 250 to 350 milliamp test light and measure voltage with a BMM while the test light is connected. Conductor sizes 24 gauge, 0.5 millimeters or smaller, are generally used to carry approximately 1000 milliamps, 1 ampere or less. Conductor sizes 20 gauge, 0.8 millimeters or larger, are generally used to carry 1 ampere, 1000 milliamps or more. If voltage drops during that loaded test, excessive resistance is indicated. For circuits carrying more than 1 ampere, load the circuit with a similar current device, such as a brake light bulb. Again, a voltage reduction during loading points to excessive resistance. For higher current circuits, voltage drop is the better method. Check ground circuits by measuring voltage drop during component operation or attempted operation. Use an ohmmeter on ground circuits only with the battery disconnected. Expect less than 2 ohms for most small diameter, 18 gauge and smaller wires, and less than 2 ohms for most wiring harness circuits. A standard DMM ohmmeter's low resistance resolution, approximately 0.1 ohm, limits its accurate use to circuits carrying less than approximately 5 amperes. If you reverse the DMM leads, the resistance reading should not change unless a semiconductor is in the circuit. If it changes without one, to check for unintended continuity to ground, disconnect both ends of the suspect circuit and measure between that circuit and ground. The expected result is resistance greater than 10,000 ohms. To check for unintended continuity to another unpowered circuit, disconnect both ends of both circuits and measure between them. Again, expect resistance greater than 10,000 ohms. To check for unintended continuity to a powered circuit, disconnect both ends of the suspect circuit, turn ignition or run power on, and measure voltage from the suspect circuit to ground. The expected result is no voltage present. Back probing is only for cases where the circuit must be tested under real operating conditions, or where voltage drop has to be measured. For voltage drop work, expect less than 5% of circuit operating voltage. Use back probes made for the job, and do not force probes into connectors. Do not back probe for a single point voltage check when 0 volts could be a valid result, because a bad probe contact can look the same as 0 volts. Do not back probe continuity or open circuit checks with an ohmmeter either, because a bad contact can look like an open. When jumper wires are used, always use fused jumper wires. The recommended universal testing jumper wire fuse is 5 amperes or less, unless the load requires a larger fuse. Use flex probes or an equivalent to protect terminals. But remember, flex probes are not intended to carry high current greater than 5 amperes. Before repairing the failed circuit, find and examine the actual fault, correct the root cause, and repair any adjacent wiring that was damaged. Do not just add a new wire in parallel with the old one without understanding why the circuit failed. For voltage drop measurement, connect the voltmeter at the beginning and end of the suspect circuit, then operate or attempt to operate the circuit so power is available to flow. A 0 volt reading during voltage drop testing means either the voltmeter connections are bad or the component has not been turned on. In 12 volt circuits, normal circuit loss is usually less than 0.5 volts, or less than 5% of circuit operating voltage. Voltage indications greater than 0.5 volts indicate abnormal voltage loss. For a voltage in, voltage out check, connect the negative voltmeter lead to ground or the battery negative terminal. Operate the circuit, then measure the power side and the ground side of the load. The power side should be within 0.5 volts of battery voltage. The ground side should be greater than 0 volts, but less than 0.5 volts. A reading of 0 volts or source voltage points to an open circuit. After the confirmed fault is corrected, keep verification separate from testing. Confirm the original concern is no longer present, and do not claim a repair that the testing did not prove. Takeaway: for P0174 on this truck, use the code as direction, not as a parts order. Confirm the concern, handle circuit codes first, inspect the air, fuel, wiring, connector, fluid, and exhaust basics, and only move into electrical testing with the circuit loaded and protected. If the path needs a P0174 specific pinpoint routine that is not present here, pause, recheck the earlier diagnostic path, and avoid guessing. For more diagnostic training, visit stepdiagnostics.com.